today's lecture, you will learn about how to do data visualization using Seaborn library. So we'll learn how to create basic plots using Seaborn library. So those plots are scatter plot, then we will do histogram, then we'll do bar plot, then box and whiskers plot, and then pairwise plots. So let's get started. So Seaborn, what is a Seaborn? So Seaborn is a Python data visualization library based on Matplotlib library. So it provides a high-level interface for drawing attractive and informative statistical graphs. So let's see how to do a scatter plot using Seaborn library. We had already seen in the Matplotlib library. So scatter plot of price versus age we will do in this, and then with the default arguments. So first what we have to do is we can call the Seaborn library by calling SNS, that is alias for Seaborn library. I will show you how to do that. Then sns.set, first we will set the style or theme for the plot. So style equal to dark grid, so we'll use dark grid theme. Now we'll draw the scatter plot. So for that we have to call a function called regplot. So that is a regression plot. So inside that we have to pass our x coordinate. So I'm passing x equal to cars data age. So this is the column from the data frame, and in the y-axis I want price, so I will pass y equal to data frame and slicing operator and the price. And if we run that, we'll get this plot. So this is scatter plot, and along with that you might have noticed there is a line here. So this line is called as regression line, and by default that line is true. So for that a variable is used, that is fit underscore reg equal to true. So by default it is true, that's why the line is displayed here. If you want to remove it, you can just add it here along with the regplot function, that fit reg equal to false. So what it does, it estimates and plots a regression model relating the x and y variables. So it calculates the coefficient of x variables and plots a line through the scatter plot. Let's go to our Jupyter notebook, and here we have to import the Seaborn library. So for that type Seaborn as SNS. So SN is a alias for Seaborn library. So whenever we have to call any function from Seaborn library, we will call SNS, then we'll call the function name. Now we'll start the scatter plot. We'll just change the markdown, and now what we can do, we'll set the theme. For that we'll call set function from SNS, and we'll pass style equal to, there are many styles, so I will use particular dark grid. This is default style also. And now we'll draw the regression plot or scatter plot, you can see. First we'll pass the x-axis. So for that we'll call our data frame, then a slicing operator. Inside that we'll pass age. Then for y axis we'll call the price column, and if we run, along with the warning, we got our scatter plot. So you can see we have a regression line here, and you can see the negative correlation. As the age of the car increases, the price of the car decreases. So what we can do, I'll show you how to remove that line. For that we'll pass fitreg equal to false variable. Now you can see the line is not present. So these are called markers, and these 0, 10, 20, 30, these are called x ticks labels, and these are y ticks labels, and these are pertaining to price, and these are pertaining to age. Now let me show you how to change the marker. So we have default marker, that is a circle. You can change the markers also here. For that we'll set the marker variable, and it will take a string and we pass star. And if you run this, now you can see all the circles are changed to stars now. So there are other parameters also, so there are options for markers also, you can go through that. in the documentation. I'll give the link in the documentation. Now this is for two variables, price and age. So if you want to for three variables like fair type, so these were two numerical variables. So what if you want to add one more categorical variable? So for that, how we can do, I'll show you that. So if you have scatter plot of price versus age and you want to do it by fair type, so you can do that. So for that you have to use a parameter called hue parameter, including another variable to show the fuel type categories with different colors. So there is a function for this in Seaborn library called lmplot. So this helps us to add another categorical variable in the numerical variables scatter plot. So for that we'll pass x equal to age, y equal to price, and data equal to cast data. So this is a data frame, and when we pass data equal to cast data, the x and y axis are automatically taken from this data frame as age and price. You don't need to use slicing operator. And now we'll do fit reg equal to false. We don't need the regression line, and then we'll pass hue equal to fuel type. And we also want legend. So to know which fuel type is which color, we will include legend equal to true. And the palette, that is a colors scheme which we'll use, is set 1. So I will show this by running. We'll type sns dot lmplot. Inside that we'll include x equal to age, comma y equal to price, comma data equal to the data frame. We have cars data, comma, then we don't want regression line equal, so filter equal to false. Then the hue parameter, we have hue parameter as fair type. Then legend we want equal to true. Then palette, so palette we are setting as set 1. So these are predefined values. So if you run this, we got a nice plot along with the fuel type. So you can see fuel types, so these are called legend, and the red color stands for diesel fuel type, green color stands for CNG, and blue color stands for petrol. So you can see there are more number of blue colors, that is petrol fuel type. And you can see as the age of the car increases, the price of the car decreases, that is negative correlation. Along with that, the prices of the car is very high for diesel fuel type when the age is very new, and as the age of the car increases, for all the fuel types, the price of the car decreases. So let's get back to our slides, and you can also change the scatter plot by using the different markers such as transparency, shape, and size. So you can increase or decrease the transparency, the shape of the data points or the markers, and the size of the markers. So this you can get through the documentation. So for Seaborn docs, if you go, there is a whole lot of documentation provided. So what we can do, we are doing for, so markers, if you search, if you go seaborn.scatterplot, so you can get the color palette. And if you go down, so markers you can change. So these are some examples given here. You can see, you can get the legend inside the scatter plot. You can increase the size and decrease the size. You can give sizes equal to 20, 200, like that. And there are different palettes. You can select CMap, etc. I'll encourage you to go through the docs also to get better understanding of different types of plots and how to draw it. And I will give the link of the documentation in the description of the video. Histogram. So how to draw histogram using Seaborn library? So for that, there is a function called plot, and inside that we have to pass the variable which we want to include. So for the x-axis, I'm giving age, and histogram is by default includes kernel density estimate. So what is kernel density estimate? So it is the curved line along the bins or intervals or ranges of the frequency of the age. So let me run this. And now we'll call the SNS library and we'll call it this plot. Inside that we'll pass cars data equal to or slicing operator age. If we run this, we got the plot along with the kernel density estimate from, you can see the 0.000 till 0.025, and this is the line which is created, and you can see we are not getting the frequency exactly, we are just getting the kernel density estimate. So if you want to remove the kernel density estimate, what we can do, we'll just pass KDE, that is kernel density estimate variable, equal to false. If you run, you can see now we've got the frequency as y-axis and age of the car as the x-axis. So age in the months format, and you can see for 60 to 80 months, that is 5 to 6 years, we are getting maximum number of cars. So that is from 100 to 140, more than 140, and that KDE is now gone. So now let's show you how to regularize this. So for that we can create bins equal to 5. So what it will do, it will organize all the different intervals or bins into 5 bins. You can give as many bins if you want, but to better understanding I am giving 5 bins. And now you can say from 65 to 80 we are getting more than 400 cars. And now let's see how you can draw bar plot. So bar plot we had earlier seen in the Matplotlib library, it was for categorical variables. Same way we will do for SNS Seaborn library. So here categorical variable is fuel type. So this is another way to write the x-axis. So we'll call count plot function. Inside that we'll give x equal to fuel type, and then we have to use the data frame name. So data equal to cars data. And this is the way by which we don't need to use the slicing operator along with the column. So this will create a bar plot for the frequency distribution of fuel type of the cars. So let's do that, and I will show you how to do it. So this is bar plot, and it is marked down, and if we run, now let's use the second library, sns dot count plot. We'll give x equal to fuel type, and then data equal to cars data. As you can see, we got a nice bar plot which has diesel, petrol and CNG as fuel types, and you can see petrol has the maximum number of cars, and it is near 1000, and CNG is very less, and diesel also has very less, that is around 100 cars. Now let's see how to do the grouped bar plots. So grouped bar plots actually is we are including one more variable along with the fuel type. So group bar plot of fuel type and automatic. So we'll include the transmission medium of the car, manual or automatic. So for that we are including x equal to fuel type, and then the data frame into the data variable. Then we are using hue. So hue parameter is used for adding one more variable. So here we can do hue equal to automatic. Since categorical variables, we will need one variable for y-axis. So we are not touching the y-axis. We are only including hue equal to automatic. So I will show you that. If you copy this and if you add hue equal to automatic. Now you can see we got a legend here. So automatic, in the blue color, if we have in the blue color we have manual transmission, that is zero value. So you can see petrol has the maximum number of manual transmission cars. It is more than 800, and diesel has around more than 100 manual transmission cars. CNG is very less. But if you see the automatic transmission cars, petrol has somewhat around less than 100, but diesel and CNG doesn't have any cars which has automatic transmission inside it. So this is how you can do the grouped bar plot for having more than two variables inside the bar plot. Now let me show you. So in pandas we had done cross step to get these values inside a table. So the same thing we have done here using the visualization library. So there we had done index equal to automatic column and columns equal to field type column, and we had included drop n equal to true, and we got this result. Now let me show you the box and whiskers plot. We'll do first with numerical variables. So what box and whiskers plot of price will visually interpret is it will give us the 5 number summary. So what is 5 number summary? So 5 number summary includes minimum, maximum, three quartiles that are 25%, 50%, and 75%. So if you remember, I had given in pandas library the 5 number summary how to do that. So we had done like the cars data dot describe. We had got this 5 number summary. Here we have minimum, maximum, 25%, 50%, 75%. So this was using the pandas library. Now we'll see the 5 number summary using the data visualization library. So for that we will use the box and whiskers plot. For that we'll use price. So how to do that? So we'll call box plot function from Seaborn library, and we'll give the y-axis as cars data price. So why we do the y-axis as price? If you want it to be vertical, we can use price in y-axis. If you want it to be horizontal, we can use in the x-axis. So it's better to use in y-axis. We get exact details. And why it is called box and whiskers plot? Because it contains box, and these lines are called as whiskers. So this is lower whisker, this is upper whisker. Anything above the whiskers is called outliers or extreme values. So these values are not included because they supposed to be very far away from the middle values of the data set. So let me show you how to do this. So let's make it markdown. Now what we can do, we'll call sns dot box plot. Inside that we'll give y equal to cars data. Inside that we'll include price column. If you run this, we got the box plot, and you can see lower whisker and upper whisker. So lower whisker is around 5,000 euros, and upper whisker is around 16 to 17,000 euros. And so this lower box plot whisker is called as first quartile, and middle one is called second quartile, and the final one is called third quartile. So what is first quartile? It is the 25% of all the data values inside the box plot. So it is near to 7,500, and you can see the second quartile. This is called median. So median rise for 10,000 euros, and you can see the 75% that is third quartile. It is near the 12,500, and these are called extreme values. And these extreme value lies about 1.5 times the median values. So now I have shown you for numerical variable. Let me show you box and whisker plot for categorical variable versus numerical variable. So this is how we do the numerical versus categorical variable. So we'll pass x equal to cast data field type. So this is a categorical variable, and the y-axis will give price, that is numerical variable. So this is price of the car for various fuel types. So for that we'll call SNS alias, and then we'll call box plot. Box plot, inside that will give x equal to cars data, and the slicing operator inside that will give the fuel type, and then for y will give cars data, and the slicing operator inside that will give price. Shift enter, and now our price versus the fuel type of different cars is drawn. So you can see in the box and whisker plot of this, the median of petrol fuel type is more than the diesel and CNG. So more number of cars have median price or for petrol fuel type. And you can see diesel has the minimum valued cars. So you can see the lower whisker for diesel fuel type is less than the petrol and CNG, and you can see the upper whisker for diesel also, it is higher than the petrol and CNG fuel type. So this implies that diesel has the lowest valued car and highest valued car, and also the diesel and petrol has the outliers, whereas CNG doesn't have outliers. So median is around 10,000 euros for petrol, and it is around 8,000 for CNG, and it is around 9,000 for diesel. Now we can also include one more variable, so that will be price versus fuel type versus automatic. So how we can do that? So we have to include hue parameter, then we have to pass automatic. Let's just copy this to save time, and instead of passing this as slicing operator, what we can do, we'll include one more parameter as data equal to cars data. Next is hue parameter equal to automatic. So this would be price versus fuel type and automatic. If you run this, we are getting a grouped box and whisker plot which contains price versus fuel type and the gear transmission. So we can see there are no automatic gear transmission cars for diesel and CNG, whereas we have for petrol. So maximum value for petrol fuel type cars which has automatic transmission is higher as compared to other type of cars which has manual or other fuel types. And we can see that the lower whisker for petrol automatic transmission car is also high, and we can see that upper whisker for petrol fuel type automatic transmission car is higher than the rest of the manual transmission cars of different fuel types. And also you can compare the petrol fuel types automatic transmission and manual transmission, and you can see the difference in both of them. One has the upper whisker more, and that implies that there are more number of cars which has higher price for automatic transmission, whereas the manual transmission cars of petrol fuel type doesn't have that maximum valued car. Now we'll look at how to draw two plots in the same window. So we'll draw box whiskers plot and histogram. Let's see how to draw them in the same window. So what we'll do, we'll split the windows into two parts. For that we have a function in Matplotlib library. So we'll call the alias of Matplotlib library, that is plt dot, then we'll call the function subplots. Inside this function we have to give how many parts you want to, how many rows you want to create the windows in. So we'll create two rows, so for the two plots, then comma. Next parameter would be specification of grid, like height and width, etc. So we'll use variable called grid specs underscore kw equals to, inside curly braces we'll give our height ratios. So this is string, and this will have value in the form of decimal format. So if you want to give for the down part more value or more aspect ratio, you will give 0.85, it is 85% to below plot window, and upper plot window will give 0.15. So this comes down to 100. This you have to put into a parenthesis like a tuple, and both of these values will be saved in these two parameters. So first parameter is f, that is for figure, comma. The second parameter I have contained into a tuple so that they both share the same value. So one is axis for box plot, that is ax underscore box, comma, then axis for histogram, that is ax underscore hist. So they will have the same value, that's why I have included them into the same parameter. So now what we can do is we'll add these lines to create the two plots. So for that we'll call the Seaborn library alias essence.boxplot function. Inside that will give the data frame column we want to include, that is price, then comma, the axis which we want to include. So we'll give ax equal to ax underscore box. So this will save the computed value ax box into this variable. Same way we'll draw for histogram, that is by using distplot function of Seaborn library. We'll give price as first parameter and then we'll give ax equal to ax underscore hist. Then we don't need the kernel density estimate, so we'll make it as kd equal to false. So now if you see the plot given below, you can see there are two plots. One is box plot and it is in horizontal format, and we have the histogram that is in without the regression line. Let me show this by running it. So we'll first box fixer and histogram in the same window, and we'll make this as markdown. Now we'll use a code. So first will be figure. So for that we have used f variable, and the second one will be the axis. So I'll give axis. First parameter is x box and second parameter will be x underscore dist, and that will be equals to, we'll call plot alias pid dot subplot function, and inside that we'll give two rows we want to create, then the grid specification underscore kw equals to, open the curly braces, inside that we'll give the height underscore ratios colon, then we can give a tuple. In the tuple we'll give the first one we want 0.15, then second one we want 0.85. So this comes down to 100 or 1. Now if we run this, we'll get two row wise plots in the same window. So now what we can do, we'll set or both the plots by calling SNS Seaborn library. So first one will be box plot, and we'll give cars data slicing operator, and we'll give price, and then we'll give axis equal to ax underscore box. Run this, it is not taken. Same way we'll go for SNS for histogram. So dist plot, and we'll give cars underscore data, the slicing operator and the price column, then ax underscore hist as our axis value. Then we don't want kernel density estimate, so we'll give it is kd equal to false. And if we run this now, what we can do, we'll include both of them in the same window, and if we run this now, we got both the plots in the same window. So we have box plot here, and we can clearly see the price from 5,000 to 30,000. The 10,000 is the median value, and less than 5,000, that is around 3,500 something. We have minimum value, then we have around 16-17,000 we have maximum value. So same way we can see the count of the histogram, and we can see the count, that is number of cars in the price. So we have around 8,000 euros We have a lot of cars, more than 150. So this is how you can have more than two plots in the same window. Let's just clear this. Okay, so next I will show you is pairwise plots. So what pairwise plots are used for? They are used for plotting pairwise relationship in a data set. What is pairwise relationship? I will show you that in this couple of minutes. So it will show the relationship between all the different variables in a particular data set, and that would be a pairwise relationship. So it creates a scatter plots for joint relationships and histograms for univariate relationship. So what is joint relationship and what is univariate relationship, I'll show you in a couple of minutes. So this is the code format we have to use. We have to use SNS dot, we have to use a function called pair plot, and inside that we have to give our data frame name. So we have cars underscore data, and then we have to give the kind. So which kind you want to include. Scatter we will give for scatter plot, and then the hue is the parameter on which we want to calculate the pairwise plot. So we'll include field type, and now if I show you the output, so this will be output. So let's run and see. We call SNS library, then pair plot, and inside that we'll give the data frame. Then the kind we want to include is scatter, because we like scatter plots. Then hue, we want to do this pairwise plot by using field type and all the rest of the columns. So if you run this, we got a warning. Okay, we got plot. It took some time, so our plot is wrong. Let me zoom out a little bit. Okay. So one thing I want to show you here is, so I hope you can see here, we have price, then age, then kilometers. These are all the columns, and here also we can see all the columns: price, age, kilometer. So we'll consider price first in the x-axis and the price in the y-axis. So when we have price and price, that is same variable, we get a histogram, that is univariate distribution, because only one, uni means only one, so only one variable is involved, so that is called univariate distribution. For that we are using histogram, and you can see the KD is also put automatically. And same way you can see age and the age itself. So all the diagonal boxes are histograms because they are actually the column distribution of itself. So that's why it is a univariate distribution of histogram. And the other ones like price versus this one, price versus age, it is, you can see bottom age it is. So that is scatter plot because it is not univariate, it is joint relationship of two variables, that is price and age. So we can see the negative correlation, and you can see the red, blue and the green color. So those are fuel types. Here you can get see the legend. Diesel is blue actually, petrol is orange, and CNG is green. So you can see petrol is more here, orange color. Same way we can see the pairwise relationship for all the different variables. So price versus kilometer, then you can see price versus HP. Same way we can see for age versus price, then we can see age versus kilometer, then kilometer versus price, like that. And you can see the positive correlation here, that is between kilometers and age. So as the age increases, the kilometer will also increase. So this is a positive correlation. So we can get more easily the insights or pairwise relationship between all the variables. And some scatter plots are don't have any correlation, so that's why they are like this. You can see it's a scatter all over the place. They have no correlation particularly, that's why they are like this, scatter all over the place. So this is how you draw a pairwise plot. So I have used pairwise plot with respect to field type, You can also include different variables. So the summary. So we have learned how to create basic plots using Seaborn library. First one we did was scatter plot, and then we did histogram. So for that we had used list plot function, and for bar plot we had used count plot, and in that we had used grouped bar plots. Then we did box and whisker plot. Inside that we did box plot, then box and whiskers plot, and then grouped box and whiskers plot. Then in the end we did pairwise plots. So guys, thank you for watching. I will see you in the next video.